Hello everyone, very good morning and happy Dashahara. This is Sanjay Rathi. How are you guys? So today we are going to discuss some important questions from transient, RC circuit, RL circuit and what RLC circuit. Right, and as you know this topic is important for all competitive exams and that's why you have to get the command over that guys. Okay, और इस बीच में आप लोगों के लिए एक important news भी है. Now it is what IRMS, that is Indian Railway Management Service, again through Engineering Services exam. Okay, तो अब आपको अपॉर्चुनिटी मिलेगी. देन स्टार्ट योर प्रिपरेशन गाइस. अभी कंपटीशन काफी कम है, लोगों को अवेयरनेस नहीं है, उन्होंने अपनी प्रिपरेशन स्टार्ट नहीं की है. तो जो अपनी प्रिपरेशन जितनी जल्दी स्टार्ट करेगा उसको मिलेगा एक एक्स्ट्रा एज फॉर IRMS, that is Indian Railway Management Service. So let me know that sound quality, picture quality, everything is fine. 1 minute. प्रिपरेशन स्टार्ट नहीं की है. ओके, तो अपने कमेंट जरूर दीजिएगा. व्हाट यू थिंक अबाउट द IRMS. इफ यू वांट टू गिव एनी सजेशन, यस प्लीज यू कैन आस्क. राइट, तो लास्ट 3-4 सालों से जो हो रहा था थ्रू व्हाट सिविल सर्विसेज एग्जाम, नाउ इट इज व्हाट थ्रू इंजीनियरिंग सर्विसेज एग्जाम. और एक और अपॉर्चुनिटी अभी आपके लिए है कि वो रीशेड्यूलिंग भी हो सकती है डेट. इंजीनियरिंग सर्विसेज एग्जाम का प्री पोस्टपोन भी हो सकता है. ओके, जो भी नई डेट आएगी मैं आपको अपडेट करूंगा. यू विल गेट एक्स्ट्रा टाइम फॉर इंजीनियरिंग सर्विसेज एग्जाम गाइस. अगर ऐसा होता है तो फिर आपको एक गोल्डन चांस है इस बार ये इस एग्जाम को क्रैक करने का. ओके, तो मेरा एक्सपीरियंस का फायदा उठाइए. ऑलरेडी आई हैव क्वालिफाइड एंड सेलेक्टेड फॉर इंजीनियरिंग सर्विसेज एग्जाम. ओके, 4 टाइम्स एंड आई वर्कड एज डिप्यूटी डायरेक्टर. तो ये आपको मैं अपना एक्सपीरियंस शेयर करूंगा कि हाउ वी कैन क्रैक दिस एग्जाम विद व्हाट टॉप रैंक, वेदर इट इज ऑब्जेक्टिव और कन्वेंशनल और व्हाट इंटरव्यू, सब कुछ. तो चलिए आइए देखते हैं जरा. नाउ नो, अब IRMS में जो आएगा दैट इज व्हाट टेक्निकल फील्ड में आप जैसे पहले होता था इंजीनियरिंग सर्विसेज वैसा ही होगा. जैसे आपका रेलवेज में जो पोस्टिंग होती थी फॉर इलेक्ट्रॉनिक्स, फॉर इलेक्ट्रिकल, मैकेनिकल एंड सिविल के लिए एंड स्टोर्स के लिए, तो ये सब टेक्निकल पोस्ट है. तो अभी भी वैसे ही होंगे थ्रू व्हाट इंजीनियरिंग सर्विसेज एग्जाम. राइट, जिसके बारे में मैंने एक डिटेल वीडियो बनाई है, तो प्लीज गो थ्रू दैट और स्टार्ट योर प्रिपरेशन सभी. राइट, तो आपको और हो सकता है अभी तो 30 जो है वो है मैक्सिमम एज फॉर जनरल कैटेगरी एंड सम देयर इज सम एज रिलैक्सेशन फॉर व्हाट OBC, SC एंड ST. लेकिन देयर में भी अपॉर्चुनिटी हो सकता है कि आपको डेट भी एक्सटेंड हो जाए, लेकिन उसके बारे में मत सोचिए. आप अपनी प्रिपरेशन स्टार्ट कर दीजिए. इफ यू आर इन 3rd ईयर अगेन, देन स्टार्ट योर प्रिपरेशन फॉर गेट एज वेल एज इंजीनियरिंग सर्विसेज, बिकॉज थ्रू दिस डायरेक्टली यू आर गोइंग टू बिकम व्हाट क्लास 1 ऑफिसर. बीच में आपका रेलवेज हटा दिया था तो क्या हुआ, उसका इंजीनियरिंग सर्विसेज का चार्म थोड़ा कम हो गया. अब नाउ अगेन दैट इज अ वेरी ल्यूक्रेटिव पोस्ट गाइस. एक क्या होता है, बहुत ही चैलेंजिंग जॉब है, बहुत सारा आपको एक्सपीरियंस होगा, अलग अलग पोस्ट पे आपकी पोस्टिंग होगी. बाद में आप डेपुटेशन पर भी जा सकते हैं दूसरे डिपार्टमेंट्स में. और जो याद रखिएगा, एक हैं जो E श्रीधरन मेट्रोमैन, जो दिल्ली मेट्रो के चेयरमैन थे, चेयरपर्सन, राइट, वो थे इंजीनियरिंग सर्विसेज ऑफिसर. तो आप डेपुटेशन में किसी भी डिपार्टमेंट में जा सकते हैं, बहुत सारी अपॉर्चुनिटी आप लोगों को मिलेगी. तो अगर आप चैलेंज लेना चाहते हैं देन स्टार्ट योर प्रिपरेशन नाउ. यस यस यस, थ्रू इंजीनियरिंग सर्विसेज एग्जाम. यस, नाउ गाइस आते हैं मुद्दे पर. दैट इज अ गेट एंड इंजीनियरिंग सर्विसेज एग्जाम 2025 प्रिपरेशन ट्रांजिएंट, RC सर्किट, RL सर्किट और व्हाट RLC सर्किट. दिस इज अ क्वेश्चन प्रैक्टिस सेशन गाइस and that is important for electrical, electronics and instrumentation branch, and this is an important topic from network. This is Sanjay Rathi. Now guys, at the end you are able to solve this type of questions. This is a very very good question. A steady state is achieved in the following network at t equal to 0. Find the time when the VCT will be maximum, and that is a question from ISRO examination. From ISRO examination guys, this is a very very important and conceptual question. We have the L and C. This is a second order circuit. At the last we will solve this type of questions. If you have any idea what is the answer for this question, everyone please write the answer in comments box. Okay, Write the answer in comments box. This is the 4 UT, 3 Henry, 30 ohm and so on. I will start from very basic and then we will reach up to this point. Okay. Then guys, this is a transient question practice. Myself Sanjay Rathi, I am having 24 years of teaching experience. I have qualified and selected for engineering services exam. इसलिए मैंने कहा पूरे कॉन्फिडेंस के साथ कोई भी इस एग्जाम को निकाल सकता है भाई, इंजीनियर होना चाहिए. ओके, तो आप अगर मिनिमम क्वालिफिकेशन आप फुलफिल कर रहे हैं और आप अपनी प्रिपरेशन स्टार्ट कर रहे हैं तो एनीवन कैन क्रैक दिस एग्जाम, right? And these are my ranks: AIR 16 in ESE 2005, AIR 21 in ESE 2008. और ये है थ्रू सेल्फ स्टडी. मैंने अपना कॉन्सेप्ट खुद बनाया, अपनी स्ट्रैटेजी खुद बनाई एंड आई हैव क्वालिफाइड एंड आई वर्कड एज व्हाट डेप्यूटी डायरेक्टर इन मिनिस्ट्री ऑफ पावर. रेलवेज में मेरी पोस्टिंग हुई थी लेकिन मेरा पैशन है टीचिंग एंड दैट्स व्हाई आई हैव क्विट. ओके, तो रेलवेज में भी मुझे मिला था और मिनिस्ट्री में मैंने काम ही किया, मिनिस्ट्री ऑफ पावर में. नाउ I have trained more than 1 lakh students for these competitive exams. This is my Telegram channel. You can join. That is Electronics by Sanjay Rathi. यहाँ आप लोगों को मिलेगा important questions, concepts, right? Test series. I'm working on it to start your preparation with me. और जो भी आपके दिमाग में doubts या जो भी आप suggestion देना चाहते हैं, yes, always welcome. Now, अब आते हैं दोस्तों फर्स्ट क्वेश्चन, वेरी बेसिक क्वेश्चन. हाउ टू फाइंड द एल इक्विवेलेंट. हाउ टू फाइंड द एल इक्विवेलेंट. ओके, समटाइम्स वी हैव टू फाइंड द टाइम कांस्टेंट. तो बिफोर फाइंडिंग द टाइम कांस्टेंट दैट इज कॉल्ड एल बाई आर और आर सी, यू हैव टू फाइंड व्हाट एल इक्विवेलेंट और सी इक्विवेलेंट. तो फर्स्ट क्वेश्चन इज बेस्ड ऑन हाउ टू फाइंड द एल इक्विवेलेंट. व्हाई? Because the time constant is given by L by R, that is unit is second, or what RC in case of RC circuit, this is in second. So first of all you have to find the L equivalent. So that is given as 4 Henry, 3 Henry, 2 di by dt and 5 Henry. Then what will be the answer for this particular question guys? Okay. Yes, PDF भी available होगी and recorded session भी available होगा, don't worry. Now this is a question. How to find the L equivalent? Remember, you can convert this diagram. This is the L equivalent, right? And that is the I. This is the I, and this is the V. So what is the relation between V and I? So you can write V is equal to what? L equivalent into di by dt. This is the first equation. Now from this diagram you have to find this and then we can compare and then we can find the L equivalent. Okay. So what is the L equivalent? Inductor का equivalent impedance कैसे निकालते हैं? Now first if you want to find, remember let this is the current I, let this current is I1. What is this current? I minus I1. Okay, then write down the KVL in this loop. You will get, let this is the voltage V. So you can write V is equal to 4, this is the L di by dt, because this is the voltage across the inductor, 4 di by dt plus 3 di1 by dt. di1 by dt. This is the equation number 1. Now equation number 2, you can write a KVL in this loop. When I am writing the KVL, it will become 2 di by dt because it is a voltage source plus 5 L di by dt of, what is the current here? I minus I1. Now it will become what? Minus. Because it is plus, it is minus, then it will become minus 3 times of di1 by dt is equal to 0. Now open the bracket, it will become 2 plus 5, 7 times of di by dt plus, this is the minus, minus 5 minus 3, 8 times of di1 by dt. Okay, please check my calculation. This is the 2 di by dt plus 5 di1 by dt. So this will become 7 and this is the 5 and 3, 8 di by dt is equal to 0. From that you can find what is the di1 by dt is equal to 7 by 8 times of di1 by di by dt. And that is the equation number 2. If you have any doubts, then you can just pin me which equation. 1, this is the 2, this is 3, that this is 4. Now 7 by 8 di by dt, put the equation 4 in 1, so you will get, put 4 in 1, v is equal to 4 times of di by dt plus 7 into 3, that is the 21 divided by 8 di by dt. Now guys, you can take common 4 plus 21 by 8 di by dt. It will become 32 plus 21, that is nothing but 53 by 8 di by dt. Can you compare this 53 by 8 di by dt with this equation, first equation, L equivalent di by dt? So what is the value of the L equivalent di by dt? Because v is equal to L equivalent di by dt. So what is the L equivalent? 53 by 8. Now tell me what is the 53 by 8, everyone. On, if you have the calculator, virtual calculator, then please find. What is the 53 by 8? 53 divided by 8, that is what? 6.625 Henry. 6.625 Henry. Is there is any answer? Yes, this is the C answer, 6.625. So why we have to find the L equivalent? For example, if you want to find the time constant of any circuit, then you have to find what L equivalent. So we have find the L equivalent across A and B, and that is the method. If there is a dependent source, don't worry about the dependent source. Always draw a circuit. We can reduce this circuit and then it will become V is equal to L equivalent d by dt. Then just current and write down one equation in this loop, write down second equation in this loop and find the equation in terms of what? I. In terms of I. So just I have find, and that is a very easy question. No need to apply the Laplace. No need to apply the Laplace, directly you can solve. Right? Voltage across the inductor is given by L di by dt. Okay then, next question guys. The answer for this question is 53 by 8 Henry. Now this is the question on what? Inductor and capacitor. That is the question from standard textbook Van Valkenburg. Which book? Van Valkenburg. Right? Standard textbook. Okay. Then बताइए, it is intended that the two networks of the figure be equivalent with respect to the pair of terminals which are identified. What must be the values for C1, L1 and L3? अभी कुछ लोगों से बात हो रही थी तो उनका कहना था कि सर YouTube में या अदर प्लेटफॉर्म में इतने फ्री कंटेंट है तो क्या उन फ्री कंटेंट से प्रिपरेशन हो सकती है? यस, व्हाई नॉट. फ्री कंटेंट से यू कैन प्रिपेयर गाइस. लेकिन याद रखिए, जब आपको कोई डाउट्स आएगा या आपको कोई गाइडेंस चाहिए तो भी आपके पास टीचर या मेंटर आपका अवेलेबल होना चाहिए. ओके. तो जब आप ओलंपिक में जा रहे हो तो आप ओलंपिक मेडल देखने जब जा रहे थे तो हर किसी खिलाड़ी के साथ एक क्या था? उनका पर्सनल कोच था. तो पर्सनल कोच का काम होता है जब आप एग्जाम में जाओगे, जब उस ओलंपिक में जा रहे हो तो आपको गाइड करे. जहां पे आप डिमोटिवेट हो रहे हैं या आप अपने ट्रिक्स को भूल गए तो उसको रिकॉल करने के लिए आपको पर्सनल अटेंशन की जरूरत होती है. और ये जो एग्जाम है ना, चाहे वो गेट हो चाहे इंजीनियरिंग सर्विसेज, ये है जस्ट लाइक ओलंपिक फॉर यू. ये आपकी लाइफ में 180 डिग्री का चेंज लाएगा और इतना आप टाइम लगाते हो डिसाइड करने में. ओके. तो ये इट्स अप टू यू. हाँ, आप अपने एक सेल्फ मेंटर बन सकते हो, आप फ्री क्लासेस देखकर भी आप पढ़ सकते हो, लेकिन यू हैव टू फॉलो व्हाट स्ट्रिक्ट डिसिप्लिन। स्ट्रिक्ट डिसिप्लिन बनाना पड़ेगा, कोई मजाक नहीं है, राइट। आप बहुत सारे यूट्यूबर को डांस करते हुए देखेंगे, लेकिन वो सब करने से आपका एग्जाम नहीं निकलेगा। आप पहले उसकी ऑथेंटिसिटी पूछिए, क्या आपने कभी इस एग्जाम को क्रैक किया है, क्योंकि टाइम इज मोर इंपॉर्टेंट। गलत हाथों में जाओगे तो एग्जाम नहीं निकाल पाओगे। क्वेश्चन को सेलेक्ट करना, स्टैंडर्ड टेक्स्ट बुक से आपको क्वेश्चन लेकर आना, प्रीवियस ईयर क्वेश्चन को इफेक्टिवली यूज करना, पैटर्न को समझना कि नेक्स्ट ईयर और क्या पैटर्न आएगा, ये सब के लिए आपको चाहिए हाईली क्वालिफाइड एंड एक्सपीरियंस फैकल्टी मेंबर्स। तो प्लीज डोंट वेस्ट योर टाइम, और जहां भी आप पढ़ रहे हैं ऑथेंटिक सोर्सेस से पढ़िए, राइट। बड़े एग्जाम से हंसी मजाक करके ये एग्जाम्स नहीं निकलेंगे, ये तय है। It is intended that the two networks of the figure be equivalent with respect to the pair of terminals which are identified. What must be the values for C1, L1 and L3? चलो अब देखो जरा, ये दोनों डायग्राम, these two diagrams are equivalent. How we can find the value? This is a 1 Henry, this is a 1 Farad. 1 Henry, 1 Farad. Now what is the impedance because of that? Z is equal to, what is the, in Laplace, what is the impedance? SL. And what is this? 1 by SC. Impedance because of that. So it will become, L is 1 Henry, S plus what? 1 by S. So what should be its Z equivalent? S plus 1 by S. Then these two diagrams are equivalent. But there are three branches connected in what? Parallel. When the three branches are connected in parallel, then guys, this is Z1, Z2, Z3. These are connected in parallel. So Z1, Z2 and Z3 are connected in parallel. So what is the parallel? What is the Z equivalent? 1 by Z is equal to 1 by Z1, 1 by Z2 plus 1 by Z3. 1 by Z1 plus 1 by Z2 plus 1 by Z3. That 1 by Z1 plus 1 by Z2 plus 1 by Z3 should be equal to what? 1 by that of this 1 by S plus 1 by S, because it is Z. Because it is Z. And in this way we can find the value of this, that and this one. Okay. Now, what is the method here? Try to understand. First of all, in this case, we want, in every case there should be one thing common, that is the S plus 1 by S. That should be common from this. That should be common from this. So that finally we can reduce it. Now here it is a 2 Henry. So what should be the value of C, so that you can find this as a common? This I am writing, you will get the idea. That 2 times of L, 2 Henry means 2 times of S plus 1 by CS. That should be equal to what? S plus 1 by S. That should be equal to X. We are just taking something common. Not S plus 1 by S. That should be equal to what? Something common. S plus 1 by S. So what is the X? You can check 2 as a common. So when I am taking the 2 as a common, it will become S plus 1 by, right, because I have taken the 2 as a common, 2CS. So that this value should be equal to 1. Then you can take S plus 1 by S as a common. And what is the value of the X? 2. So dear friends, this 2 is the value of what? Inductor. This is C is the value of the capacitor. So in that question, the product of L1 and product of C1 should be equal to what? 1. So when I am doing the L1 C1 is equal to what? 1. Then what is the C1 is equal to? C1 is equal to 1 by L1. That is equal to 1 by 2 farad. 1 by 2 farad. So just I have given the simple logic that, for example, just I am putting the L1 here. Then just I am writing the SL1 plus 1 by SC1 you can take L1 as a common. S plus 1 by S C1 L1 is equal to, if you want to take S plus 1 by S common, then this term should be equal to what? 1. 1. Then it will become, and you can take this as a common. This as a common, guys. So first term, this is what? C1 is equal to 1 by 2 farad. Similarly here, L2 C2 is equal to 1. And that's why, what is the L2? L2 is equal to 1 by C2. And what is the C2? 1 by 3. That's why it will become 3 Henry. Now we have the value of this 3 Henry. We have the value of this capacitor 1 by 2 farad. Then how we can find the L3 and C3? L3 and C3, third term. Now watch this. Watch this. This is the 2 and this is what? 1 by 2. So what is the impedance here? 2S plus 2 by S. So you can take 2 as a common, 1 plus S plus 1 by S. S plus 1 by S, first impedance. Second, this is the 3. So it will become 3S plus 3 by S. 3S plus 1 by S. Now, you want S plus 1 by S common, and this is the parallel combination of 2, parallel combination of 3 and parallel combination of, let this is what? X. So if the value of this inductor is X, so according to the L3 C3 is equal to 1. What is the value of the C3? C3 is equal to 1 by X. Okay. If suppose you are going to choose the X, it will become X times of S plus X times of what? S, and that is X is common, S plus 1 by S. Now parallel combination of 2, 3 and X. 1 by 2 plus 1 by 3 plus 1 by X, because we have this taken as a common, then it should be equal to 1. This will become 6X. This is right place, and then it will become, and this, you can equate it to what? 1, or directly you can find the value of X. This is 1 by, अच्छा किसी को confusion हो सकता है कि सर वो S plus 1 कहाँ गया? Yes, just I can write this. Parallel combination of these three. कैसे लिखोगे? 1 by Z is equal to, you can take, this is common, 1 by 2 plus 1 by 3 plus 1 by X, and that should be equal to what? 1 by S plus 1 by S, because Z is S by 1 plus S. That's why this is cancel out. And now this is the 5 by 6. 5 by 6 plus X is equal to what? 1, and therefore what is the X is equal to 6 by 5. Right? Please find the value. Check my calculation. Is there is any mistake? Oh, sorry. X is equal to 1 minus 5 by 6. One minute. One by 2 plus 1 by 3, that is what? 5 by 6 plus 1 by X, yes, that is equal to what? 1, and that's why this is become 1 by X is equal to 1 minus 5 by 6, that is equal to 1 by 6, and what is the value of the X? X is equal to what? 6. X is equal to 6. So what is the answer for this question? The answer for this question is, the value of this inductor is 2 Henry. This is 1 by 2 farad. L1 C1 is equal to 1. this is 3 1 by 3 farad. L1 L2 C2 is equal to 1, and this is 6 Henry, and this is what, 1 by 6 farad. L3 C3, and you can find, so what is the overall impedance? S plus 1 by S, and this is also S plus 1 by S, and that's why these two diagrams are equivalent. बहुत ही simple सा question है, but this is the question from what Van Valkenburg, guys. If you want to solve, I am going to solve number of questions from standard textbook. Alexander and Sadiku, Van Valkenburg, Chakravarti, and other. We have number of textbook, right? Haight and Camrelli. So, good questions from in Van Valkenburg. We have good questions in what? Transient. We have good questions in what? Two-port network. We have good questions in what? Basics. This is the questions from the basic. Find the value of the capacitor. Now, next question. I think there is no doubt. First diagram, second diagram, find the impedance. Just that is the way, because I want to take the S plus 1 by S common, and that's why I am saying that L1 C1 is equal to what? 1. So that you can take S plus 1 by S as a common. S plus 1 by S as a common. Then just that is the 2, 3 and third term is that it is X, and then find the parallel combination of these 3. Or if you want to make it easy, just I am giving you one method. If you want to make it easy, what you can also deal with what? Y. Admittance. Admittance. Some students are not comfortable with all, na? So that is no problem. But again, you will get the same calculation. What is the admittance? Because of that, it is a 1 by SL. And it will become SC. Admittance, I am talking about that. It is the 1 by S, it is the S. So what is the admittance here? Y. S plus 1 by S. Or 1 by S plus S, that is the. For similar diagram, that what should be the admittance? S plus 1 by S. Now, what is the admittance because of this? This is the 2. So 1 by 2S. And that will become what? 1 by 2. So this is the 1 by 2S. And then this is the 1 by 3. It is given. Right? So, and this is 1 by SL. Again, same procedure. But in this case, you have to add all this. You have to add all this. So you can use this method just to solve this. Okay? Okay, then next question. In my class, I have solved this question. So new students, please quickly watch this question. This is a question on what? Transient. The switch in the circuit in figure has been closed for a long time and it is opened at t equal to 0. Find Vt for t greater than 0. Calculate the initial energy stored in the capacitor. This is a very, very basic question based on first order transient, right? All new students, please focus on that. If it is written the switch in the circuit in the figure has been closed for a long time, means this is a closed for long time and exactly at t equal to 0 switch is open. Then this is the t equal to 0. For t less than 0, what is the position of the switch? Closed. When the switch is closed, always watch the source. This is the DC. If this is the DC source, capacitor act as open circuit for DC. Open circuit for DC under steady state. And inductor act as short circuit for DC under steady state. Under steady state. If anything is written, it is closed for long time, means circuit reached to steady state. But exactly at t equal to 0, switch will be open. So just before the switching, this is called 0 negative. This is called 0 negative. And under 0 negative, circuit is under steady state. Circuit is under steady state. Now, or at steady state, capacitor acts as open circuit for DC. And remember guys, capacitor does not allow sudden change of voltage. So if you are going to find the voltage at 0 negative, that same voltage is here 0 positive. And that's why we are saying that 0 negative is equal to what? 0 positive. This is. Now this is the value at steady state, and that is the value is called initial condition. Initial condition. And this is for t greater than 0. This is for switch closed. For switch closed, it is steady state. For switch open, it is initial state. It is switch open here. It is the initial state. And remember, voltage across the capacitor will remain continuous. तो ये continuous है यहाँ से यहाँ तक. Now VC0 negative is equal to VC0 positive. How we can find the VC0 negative? Then first of all, in any diagram, under steady state means T0 negative, switch was closed, capacitor act as open circuit. Always remember what is the meaning of the open circuit. There is no current through the capacitor, 0. So what is the drop across this resistor? 0. And same voltage is here. Why? Because there is no drop across the 1 ohm resistor. So according to voltage division rule, 9 divided by 3 plus 9 into 20. Right? What is the voltage across 9? This is the, it will become 3 by 4 into 20, that is the 15 volt. This is the initial voltage across the capacitor, 15 volt. So in this way you can find. Again, remember, capacitor act as open circuit. You have to apply what? Simple voltage division rule, concept of network, then 15 volt. Now, what is the initial energy stored in the capacitor? That is represented by the W, half of CV0 square. This is called initial energy. Half of 20 millifarad. This is the value of the capacitor into V square into 15 square. So this is the 10, and guys, this will become 225 into 10 raised to power minus 2 joule, means 2.25 joule. Very simple thing. 2.25 joule. And that is the question from Alexander and Sadiku. Question from standard textbook, guys. Okay. तो आपने अगर आपके पास बुक है तो अच्छी बात है, नहीं तो आपको मैं दिखा दूं. ये है अलेक्जेंडर एंड साडिको. मैं वैन वेल्केनबर्ग की भी कॉपी मंगवाता हूं आपके लिए. दिस इज द अलेक्जेंडर एंड आई हैव द 5th एडिशन, फंडामेंटल्स ऑफ इलेक्ट्रिकल सर्किट. ट्राई टू सॉल्व दिस क्वेश्चंस, या फिर मेरे साथ ट्यून रहिए, आपको पता चलेगा किसमें से कितना पढ़ना है. ओके. 15, 2.25 joule is the answer for this energy. And what is the initial voltage when the switch was closed? 15 volt across the capacitor. Capacitor does not allow sudden change of voltage. Now, अब आते next. Now you have to find the voltage across the capacitor when the switch is open. So what is the condition? For t greater than 0, switch is open. So you can cut this circuit. We have this portion only. In this portion, we have only 2 resistors and 1 capacitor. So what is the R equivalent 10 and what is the C 20 millifarad? So what is the time constant of the circuit? RC. So it will become 10 into 20 millifarad into 10 raised to power minus 3, and that's why it will become 0.2 second. The time constant of the circuit is 0.2 second. Always remember, if this question is asked, find the time constant, then we have to find the time constant for t greater than 0. So for t greater than 0, this is the diagram because it is the switched off, and the time constant for that portion is 0.2 second. Now we have the initial voltage. What is the initial voltage? 15 volt. Now just find the final voltage. Finally, there is no battery, no external battery, and that's why this capacitor will discharge through that. and the capacitor will discharge through that. So what is the final means at t equal to infinite, voltage is 0. Voltage across the inductor will be 0. पूरा कैपेसिटर रजिस्टर के थ्रू डिस्चार्ज हो जाएगा. And what is the energy dissipated across the resistor? 2.25 joule. 2.25 joule complete energy will discharge through this. This is called a source free RC circuit. So how we can find the equation? Always remember it is a first order circuit. So what is the VT? V final minus V final minus V initial e raised to power minus t by tau. That is a general equation for first order circuit. Very, very important one. So what is the final value? 0. What is the final value? 0. What is the initial value? 15. E raised to power minus t by RC. What is the RC? 0.2 second. Time constant is 0.2 second. And that's why you will get the answer 15 e raised to power minus 5t. And this equation is valid for t greater than or equal to 0. And that is the answer. That is the answer, guys. So in this way you can find. In this way you can find. Now watch it. What I have written, t greater than or equal to 0. Yes, it is correct. This is valid for t equal to 0 as well as this is valid for what, t greater than 0. Because capacitor does not allow sudden change of voltage, guys. So what is the diagram here? For example, if you want to draw the diagram, then voltage across the capacitor is given by this is 0. This is called 0 negative. For 0 negative, what was the value? 15. For long time the switch was closed and capacitor charge up to what, 15 volt. There is no change under steady state. For 0 positive the switch is open. Now the capacitor start discharging from this point. And exponentially it will discharge, and at t equal to infinite it will become 0. Now guys, watch this point. Is there is any discontinuity? No. Voltage across the 0 positive is equal to what? 0 negative is equal to what? 15 volt. And that's why if I am going to write t greater than 0, that is correct one. Right? VCT. Okay. Now, this type of questions. Then at the same time, if the current is asked, current, remember, just this question only voltage is asked, so I have given you the answer. What is the answer question here? Yes, this one. For VT for t greater than or equal to 0, so switch is opened, find the equation for the VT. First find the initial condition. Always find the initial condition. Find the initial energy. Joule. Then for t greater than 0, draw the diagram, find the time constant, find the initial value, find the final value, and write down the equation. Okay. Now, if the current is asked, and that is the direction of the current. For example, in question this is given I, or it is given IC, that IC is given. If the current is asked, then this is the diagram. If this is the direction of the current and this is the plus and this is the minus, always remember if the current entered through the plus leaving the minus, what is the equation of the current? C dVc by dt. C dVc by dt. So what is the C here? 20 millifarad. D by dt of 15 e raised to power minus. What is this? 0.2 means what? 5. 10 divided by 2, it is 5. It is 10 raised to e raised to power minus 5t. 5t. Now you can differentiate it. It will become 20 into 10 raised to power minus 3 into 15 into 5 with negative sign e raised to power minus 5t. Then you can multiply minus 20 into 15, 300, or 300 into 1500, 1.5 e raised to power minus 5t. Okay, this is the 20 into 15, that is the 300 into 5, 1500, and 10 upon 1000, 1.5 e raised to power minus 5t with negative sign. And that is the current in ampere. Now what I want to say, please watch that. This current is what? Negative. First point. Negative means the current, the direction of current, the current is not moving in this direction. The current is moving in opposite direction. This is the IC, but actually the current is moving in a what? Opposite direction. From this point to this point. Means this capacitor will deliver the energy. Always remember. If the current is moving from negative to positive in this direction, what is the value? 1.5 e raised to power minus 5t. Then what about this capacitor? Capacitor will deliver energy to resistors. तो ये हो गया आपका 1.5 e raised to power minus 5t. यहाँ से ये पूरा एनर्जी डिलीवर कर देगा एंड फाइनली द वोल्टेज अक्रॉस द कैपेसिटर विल बिकम 0. तो यहाँ पर ये कैपेसिटर बिहेव कर रहा है एक्टिव एलिमेंट जैसा. दिस बिहेव लाइक व्हाट? एक्टिव एलिमेंट. इट इज जैसे आपका मोबाइल है ना, ये देखो, पहले आपने इसको कनेक्ट किया, कैपेसिटर चार्ज हो गया, फिर आपने मोबाइल को डिस्कनेक्ट कर दिया, अब कैपेसिटर क्या हो रहा है? यूज हो रहा है और डिस्चार्ज हो रहा है. जब फुली डिस्चार्ज हो जाएगा तो फिर से चार्जर लगा दो. ये देखो, फिर से आपने चार्जर लगाया, फिर से मोबाइल क्या हो जाएगा? चार्ज हो जाएगा. राइट. अब आपका अगर ये सोर्स है, मान लीजिए इसको आपको फीड करना है, तो जब आप मोबाइल लगा भी दोगे तब भी इसको कुछ ना कुछ करंट मिलता रहेगा, और जब आप इसको हटा दोगे तब भी इसको कैपेसिटर करंट प्रोवाइड करेगा. इसको क्या कर रहा है? डिस्चार्ज होते हुए. ओके, तो दोनों केस में 9 ओम के अक्रॉस आपको करंट मिलता रहेगा. इसलिए आपने कभी देखा होगा कि जब आप मोबाइल को चार्ज कर रहे हो ना, मोबाइल को चार्ज कर रहे हो तब भी आप मोबाइल को यूज करते हो. यस? अरे कमेंट्स में लिखिए यस और नो. ड्यूरिंग चार्जिंग वी आर यूजिंग अवर मोबाइल. तो ये भी है दोनों वे. नाउ अब दूसरी बात क्या है, देखिए, दिस इज द नेगेटिव मीन्स द डायरेक्शन इज चेंज. सेकेंड थिंग, it is written 1.5 e raised to power minus 5t. This equation is valid for t greater than 0. We can't write t equal to here. Why? ये देखो, छोटी छोटी बातें ना आपको इंजीनियरिंग सर्विसेज मेंस में आपको नंबर दिलवाएंगे. You can't write t greater than or equal to 0 because, right, capacitor does not allow sudden change of voltage, but it allows the sudden change of what? Current. So what was the current for t greater than less than 0? Watch this. When I have said this act as open circuit, what was the current here? 0. IC 0 negative was 0. Yes, it is open circuit at t equal to 0. Under steady state it was open, and that's why the current is 0 and the voltage is what? 15 volt. But now what is the current at exactly at t equal to 0? The exactly at t equal to 0 the current is 1.5 ampere negative. 1.5 ampere negative means capacitor allows sudden change of current. So draw करें जरा. Finally if that is asked what is the plot for the current, remember which type of plot here. This is the time, this is the IC, and this is given here IC. This is the negative. So under steady state what was the current? 0. Right, this is the 0. For t 0 negative it is 0. Suddenly the current switched to what? Minus 1.5. Exactly at t equal to 0. IC is what? G equal to 0 plus. Put the 0, you will get minus 1.5. Sudden change of current, and then exponentially decreasing function, and finally it will become 0. You will get this type of curve. So there will be the question, what is the curve for voltage across the capacitor, what is the curve for the current through the capacitor, so this type of curve you will get. So there is a discontinuity at zero negative zero. From zero negative to zero positive, there is a discontinuity, abrupt change, sudden change in current in case of capacitor. Okay, that is the rule. No doubt, finally at t equal to infinite, current will also become zero. At t equal to infinite, current will become zero. कैपेसिटर विल फुल्ली डिस्चार्ज. तो यहां पर क्या नहीं लिखना है, देखो इक्वल टू नहीं लगाया है मैंने, टी ग्रेटर देन जीरो लगाया, और वहां देखो क्या लगाया था मैंने, टी ग्रेटर देन और इक्वल टू. इट इज करेक्ट फॉर कैपेसिटर, बट दैट इज करेक्ट फॉर व्हाट, करंट. अगर इक्वल टू लगा दोगे ना, गलत है, रॉन्ग, because we can't define the current exactly at t equal to 0. there is a discontinuity. okay, next question. अब बताओ, एक क्वेश्चन के कितने पार्ट हैं? आपको लगता होगा ना सर इंजीनियरिंग सर्विसेज एग्जाम में या गेट में या इंटरव्यू में, इसरो में, डीआरडीओ में क्या एक्स्ट्रा ऑर्डिनरी पूछ लेता है. छोटी छोटी चीजें आपको ऑब्जर्व करनी है, आपके दिमाग में सेट करनी है और वो बताना है. तभी आप इंटरव्यू क्रैक कर पाओगे, तभी आप कन्वेंशनल में आंसर अच्छे लिख पाओगे, कभी आप नोट्स लिख पाओगे. बड़ी बड़ी चीजें तो सबको दिखती है ना, जब भी आप किसी चीज को देखने बोलोगे तो सब कुछ दिख रहा है. बहुत ही छोटी छोटी बातों को आपको एक्सप्लेन करना होगा जब आप क्वेश्चन राइटिंग कर रहे हो, और ये इस तरीके से बहुत ही इंपॉर्टेंट होता है ये सब रिप्रेजेंटेशन. यहां पर नाउ डायग्राम प्रॉपर बनाइए. हर क्वेश्चन में देखो डायग्राम ये आ गया, दिस इज द वोल्टेज अक्रॉस द कैपेसिटर, राइट, यूनिट डाल लीजिए वोल्ट. दिस इज द टाइम वी आर एक्सप्लेनिंग इन सेकेंड, राइट, एंड सो ऑन. व्हाट इज द टाइम कांस्टेंट, tau, that is a 0.2 second, so on. Now next question, if the switch in the figure opens at t equal to 0, find for t greater than or equal to 0 and wc0. wc0 means energy. It is an assignment for you everyone. Energy stored at t equal to 0. Again, switch close, you can find the parallel combination of this. You can find the voltage across the capacitor when the switch is closed. Okay, you can find the time constant, and then it is a source free RC circuit. So there will be two diagrams, one when the switch is closed, I am giving you the hint, 0 negative, capacitor will act as open circuit, means what is the current through the capacitor, it will become 0. What is the parallel combination of that, 3, and this is the 6. Now you can, according to voltage division rule, you can find the voltage across the capacitor. Then for t greater than 0, that is the diagram. What is the parallel combination of 12 and 4, 3, and this is the 1 by 6. Now the capacitor will discharge through this resistor. Capacitor will discharge through this resistor. Only RC circuit, time constant RC. What is the final value? 0. What is the initial value? You have to find from this diagram. Only the initial value is required. So this is a, according to voltage division rule, you can find this divided by that 24. ओके, तो देखिए मैंने तो सॉल्व ही कर दिया बात करते करते. कितना आ रहा है, 8 वोल्ट. तो यू कैन नाउ connect. Yes, please tell me what is the answer. What is the time constant for this? So everyone happy Dashera, and for Dashera, just because now this is a new notification about the IRMS, and that's why we are giving you the opportunity to start your preparation with us. Go through our apps, that is you can install from the Google Play Store, Prep Funda for GATE and ESE by Sanjay Rathi sir. Okay, so you can search for that, or otherwise you can download the link. It is given Prep Funda. So install it and go through the courses. Just we have started course for you, Super 6, Super 5, Super 4, and you have a discount for that. For just it is a Dashera offer, and you can start your preparation with us. Okay, and then remember, we have individual subject, but if you are going to join minimum 4 subject or 5 subjects, then it will be beneficial for you. आप मुझे समझ पाओगे, 5 सब्जेक्ट जब पढ़ोगे तब आपको लगेगा कि हाँ भाई 5 सब्जेक्ट आपने पढ़ लिया और 5 मैंने आपको गाइड कर दिया कैसे पढ़ना है, आप इन एग्जाम्स में टॉप कर जाएंगे. ओके, और वो जो मैंने 5 सब्जेक्ट चूज किए ना, वो दोज आर इंपॉर्टेंट फॉर इलेक्ट्रिकल एंड इलेक्ट्रॉनिक्स एंड इंस्ट्रूमेंटेशन ब्रांच. नेटवर्क है आपका, एनालॉग, कंट्रोल, डिजिटल, राइट. और आप अगर इलेक्ट्रॉनिक्स में जा रहे हैं तो देन व्हाट, ईडीसी ऑल्सो, इलेक्ट्रॉनिक डिवाइसेज एंड सर्किट. तो आप स्टार्ट कर सकते हैं योर प्रिपरेशन विद अस. ओके, हाँ, यहां पर मैं क्या करने वाला हूं, आपको नोट्स तो मिलेंगे ही, लाइव क्लासेस हैं, रिकॉर्डेड लेक्चर्स भी हैं आपके पास. सबसे इंपॉर्टेंट है ये, तो चलो आप बोलोगे कि सर ये तो सब यूट्यूब में अवेलेबल है या फ्री क्लासेस अवेलेबल है. मोस्ट इंपॉर्टेंट थिंग इज व्हाट, पर्सनल गाइडेंस. आपको अगर कोई डाउट्स आ रहा है, आपको अगर डाउट क्लियर करना है तो आप फिर देख सकते हो. और ये रेगुलर यूट्यूब में इज इट नॉट पॉसिबल, इसीलिए हमने ऐप में क्लासेस रखी हैं और अभी बहुत कम समय बचा है. दिस इज व्हाट, अक्टूबर, नवंबर एंड दिसंबर. अगर आपको लगता है कि आप इस एग्जाम में टॉप करना है, क्वालिफाई करना है, तो जरूरत नहीं है सबकी. अगर आपको इस एग्जाम में टॉप रैंक अचीव करनी है, सिंसियर एफर्ट देना चाहते हैं, असाइनमेंट करना चाहते हैं, डेली प्रैक्टिस प्रॉब्लम्स बनाना चाहते हैं, इफ यू वांट टू गिव द टेस्ट सीरीज, डाउट क्लियरिंग सेशन में पार्टिसिपेट लेना चाहते हैं, देन यू कैन ज्वाइन. तो गो थ्रू इट. अभी भी ऑफर है आप लोगों के लिए, लेकिन याद रखिए आपको कॉपी पेन एंड कैलकुलेटर लेकर बैठना है. ऐसा नहीं कि नॉवेल जैसे पढ़ रहे हो, देन इट इज नॉट पॉसिबल टू क्रैक. आपको पूरा साथ में बैठ के तैयारी करनी है, एक एक क्वेश्चंस बनाना है, एक एक न्यूमेरिकल बनाना है, जो भी आपको असाइनमेंट दिया जाए वो करना है. तो मैं आपको बता दूं, अगले 4 महीने में, अक्टूबर, नवंबर, दिसंबर एंड जनवरी, आप गेट में टॉप करेंगे. उसके बाद एक सेकेंड अपॉर्चुनिटी आएगी, इंजीनियरिंग सर्विसेज एग्जाम. उसको हम जनरल स्टडीज को भी पढ़ेंगे, एक्स्ट्रा सब्जेक्ट्स के बारे में मैं आपको बताऊंगा, मैं अपना पूरा एक्सपीरियंस आपके साथ शेयर करूंगा, और आप उस एग्जाम में भी टॉप कर सकते हैं. और इसी साल आपका करियर सेट हो जाएगा, राइट. और सीधा आप बनोगे क्लास 1 ऑफिसर. लेकिन अगर आपको लगता है कि सर कॉलेज में कैंपस आ रहा है, 3 लाख की जॉब लग जाए वही बहुत है, तो फिर ये आपका माइंडसेट है. आप बस सोचिए, और सोचिए कहां 3 लाख का पैकेज है और किसी पीएसयूज में 17 लाख का पैकेज है, 17 लाख रुपए का. ये कॉलेज के बाद आपको ये पैकेज मिल रहा है, और आपने थोड़ी प्रिपरेशन की तो ये पैकेज मिलेगा स्टार्टिंग फेज पे. जाके देखिए पावर ग्रिड और ओएनजीसी वगैरह के पैकेजेस, और जॉब सिक्योरिटी अलग है. लेकिन आप बोलेंगे कि इसको ही आपको प्लेट में सजाकर दे दे, तो ये तो पॉसिबल नहीं है. आईआरएमएस हो गया इंजीनियरिंग सर्विसेज के थ्रू, ये एक बहुत ही बढ़िया अपॉर्चुनिटी आ गई आप लोगों के लिए, इस बैच के लिए. एंड देन इफ यू वांट टू क्रैक दिस एग्जाम, तो आपको पढ़ना पड़ेगा ऑब्जेक्टिव, कन्वेंशनल, प्रीवियस ईयर क्वेश्चंस, और आपको जनरल स्टडीज भी पढ़नी होगी. ये तो चलो ठीक है, टेक्निकल, नॉन टेक्निकल सब. देन गाइस, यस, इट इज पॉसिबल टू क्रैक, लेकिन आपको प्रिपरेशन करनी होगी और आपको माइंड सेट करना होगा, यार मुझे टॉप में जाना है. देखो, अगर आपने स्टार्ट यहां से किया तो कहां तक जाओगे ये सोच लो. अगर आपने स्टार्ट यहां से किया तो फिर आपके पास तो कुछ, अभी तो 3 लाख में भी आप बचत कर रहे हो, तो 17.3 लाख में आप कितना अमाउंट बचा सकते हो और कितना अच्छे से इन्वेस्टमेंट कर सकते हो. तो हो सकता है 5 साल बाद इतना कॉर्पस हो जाए आपके पास कि आप पूरी तरीके से फाइनेंशियली फ्री हो जाएं. तो आपको 1 साल तो देना होगा, 1 साल आपको प्रिपेयर करना होगा. फिर दूसरा, सोशल रिकॉग्निशन जो है कि यार आई एम इन IOCL, आई एम इन ओएनजीसी, रेलवेज में मैं ऑफिसर हूं, राइट। और इसके बाद और एक अपॉर्चुनिटी बनती है कि आप सिविल सर्विसेज में भी जा सकते हैं थ्रू दिस ब्रांचेस इलेक्ट्रिकल, राइट। तो इतने सारे वेन्यूज तब खुलेंगे, उससे पहले आपको माइंड सेट करना होगा एंड यू हैव टू स्टार्ट योर प्रिपरेशन। और एक बात बता दूं, दैट इज नॉट फॉर द भीड़, जो भीड़ है ना उसके लिए नहीं है, झुंड के लिए नहीं है। ये कुछ ही लोग हिम्मत कर पाएंगे फॉर दिस कॉम्पिटिटिव एग्जाम्स, कुछ ही लोग हिम्मत कर पाते हैं कि मुझे यहां पर जाना है। ज्यादातर लोगों को तो यही है कि मैं नहीं कर सकता। यू कैन, आई कैन, जब ये फीलिंग आएगी देन यू कैन स्टार्ट योर प्रिपरेशन। तो थोड़ा सा प्रिपेयर कीजिए अपने आप को, और गाइड तो हम करेंगे। देखो मैं जब इस एग्जाम को निकाल सकता हूं तो कोई भी निकाल सकता है, लेकिन भाई ऐसा थोड़ी ना कि मैंने बिना पढ़े ही निकाल लिया, या मजाक कर रहे हैं आपके सामने। ओके, प्रोफाइल में जाइए, देखिए, मिनिस्ट्री में जाके पता करो कितनी पावरफुल जॉब है ये सब, और कितनी अथॉरिटी मिलेगी, कितनी रिस्पॉन्सिबिलिटी है, लाइफ सेटल्ड है, आप हर जगह आप जाते रहोगे, आपको लोग अप्रिशिएट करेंगे। इतना समझने के बाद आप इसकी प्रिपरेशन कीजिए। ओके, अच्छी अपॉर्चुनिटी आ गई, अभी ये जस्ट अभी रिसेंट डेवलपमेंट है, इसीलिए इस बैच, और साथ में डेट भी पोस्टपोन हो सकती है, तो लेकिन आप वेट मत कीजिए, स्टार्ट योर प्रिपरेशन। देन गाइस, अब आते हैं नेक्स्ट क्वेश्चन पे। ये देखो, इन द सर्किट शोन बिलो, इनिशियली द स्विच S1 is open, the capacitor C1 has a charge of 6 coulomb and the capacitor C2 has a 0 coulomb. What is the charge in the first 6 coulomb and what is the charge in the second 0 coulomb? After S1 is closed, the charge on the C2 in steady state. When the switch is closed under steady state, what will be the charge here? Now this is a very important diagram. Here we will use the concept of law of conservation of charge. Concept of what? Law of conservation of charge. Charge can neither be created nor be destroyed. First of all, I will give you the general formula, then we will solve this particular question. First, general formula for this question. Right? Now we are having R register, this is the C2, this is the C1. Normally the charge is given, otherwise voltage is also given, like the initial voltage across this, and this is R. Okay, first, if you have, in particular question, if the initial voltage is given, you can find the charge. So what is the initial charge? Q1 0 plus Q2 0. What is the Q1 0? C1 V1 0 plus C2 V2 0. Right? This is the Q 0. So always find the initial charge first. Now our charge can neither be created nor be destroyed. Then guys, what will happen? At t equal to infinite, capacitor acts as open circuit. What is the meaning of this? Capacitor does not allow current. So at the t equal to infinite, because we have the two capacitors, suppose initially V1 is greater than V2. We are assuming that V1 is greater than V2. Then what will happen? The current will flow from this point to this point. When the current will flow from this side to this side, then this capacitor will discharge and that capacitor will charge. One will discharge, one will charge. What happened? V1 increases, V1 decreases, V2 increases. Finally, at point, V1 become V2. V1 and V2 will become equal. And this will happen at what? Infinity. At infinity means we are giving the sufficient time. Under steady state, one capacitor will discharge, other one will charge, and finally the voltage will become equal. When the voltage is equal and the switch is closed, what is the current? V1 minus V2 upon R, that is equal to 0. Means both the capacitor effectively act as what? Open circuit. It does not allow the current. They do not allow the current. तो ये है, that is the concept. So first charge, then finally initially this capacitor, suppose this has the more charge than more voltage, then the current will flow from this point to this point. This capacitor will discharge, that capacitor will charge, voltage decreases, voltage increases. Finally both the voltage at this point and this point will become equal and the current will become zero, and the further charging discharging will stop, and at a t equal to infinite charge will remain same. So what is that? Infinity. Again C1 V1 infinite plus C2 V2 infinite, but at infinity both the voltages are what? Same, Vx. You can write C1 plus C2 times of what? Vx. And this is the voltage at infinity and that is the voltage at what? Initial, and both the charges are equal. And in this way you can find any question. This way you can find any question, guys. So you can equate it. When I am going to equate these two, you will get C1 plus C2 into Vx. What is the Vx? Voltage at infinity is equal to C1 V1 0 plus C2 V2 0. This is the charge at 0. This is the charge at infinite. So what is the V infinity? C1 V1 0 plus C2 V2 0. 0 means at t equal to 0 upon C1 plus C2. And that is the general formula, guys. Now you can find the final voltage across both the capacitor. Then you can find the charge also. What is the charge in first? C1 V infinite, because the charge is CV. What is the charge stored in the second? C2 V infinite. Both are same. And then that is the question. General question, general, very, very important. Right? And there is one other question in this diagram. What is the time constant of the circuit? So guys, time constant of the circuit is R into C equivalent. This is the R, it is a C equivalent. So if this question is given, what is the time constant of this circuit? Then remember, time constant of this circuit is, if suppose you are going to remove the R, this is R. These two capacitors are actually connected in what? Series. Effectively, they are connected in series. Remove the R and what is the C equivalent? Series, not in parallel. So what is the C equivalent for this? C1 C2 upon C1 plus C2. And that's why the time constant will become RC equivalent. Time constant will become RC equivalent. Right? Why I have find the time constant? If suppose it is asked, what is the equation of the current? So what is the equation of the current? Then always you have to use I is equal to I final, I initial, e raised to power minus t by tau. What is the final current? Already I have given 0. Finally, the voltage across that and this is 0, and that's why what is the final current? 0. Final current is 0, and what is the initial current? Yes, there is the initial current. This is the final current at t equal to infinite, final current. Initial current is nothing but V1 0 minus V2 0 upon what R? That is called initial current. So you can solve this equation. V1 0 minus V2 0, initial voltage upon R, and final voltage, both are equal, final current is 0. Can you find the equation of the current? Because now we have the time constant, we have the final value, we have the initial value. So guys, this diagram is very, very important, and there are different types of questions. So first question, what is the voltage at this point? Final voltage. Both are same, right? What is the charge? It is asked after charge C2 in steady state. Steady state means what? Coulomb. That is the Q2 infinity is asked. What is the initial current? It is asked. What is the final current? 0. What is the equation of the current for t greater than 0? Already I have given the equation. What is the time constant of the circuit? These all are the question on this particular diagram. Very, very important one. Now I will solve this particular question. What is the steady state charge here in this particular question, guys? It is a numerical answer type question. No negative mark, but just like a conventional. Numerical answer question means what? Conventional. You have no idea about the answer. Just put the answer. No. So guys, remember, this is the initial charge, right? And final charge. Finally, the voltage will be equal. This is the formula. And that is the time constant. Now, I am going to solve this question. First of all, so what is given here? In the circuit shown below, initially the switch S is open. The capacitor has a charge of 6 coulomb. And capacitor C2 has 0 coulomb. So already it is given. So what is the initial charge? 6 coulomb. Then after S1 is closed, the charge on the C2 in steady state. What I have said, find the voltage. C1 V1 0 plus C2 V2 0 upon C1 plus C2. This is nothing but Q1 0 plus Q2 0. C1 plus C2. Already we have the value 6 upon, what is the C1 plus C2? 1 plus 2, 3. This will become 2 volt. Right? At this point the voltage is 2 volt. At this point the voltage is 2 volt. So what is the charge stored in this? That is the asked in the question, Q2. It will become C2 V2 infinite 2 into 2, that is what? 4 coulomb. Answer for those question is 4 coulomb. And what is the stored in the C1? C1 V1 infinite 2 coulomb. So 2 plus 4, 6. Initially 6, finally 6. Easy. भाई ऑल द न्यू स्टूडेंट्स, आपको अगर कुछ भी नई इंफॉर्मेशन मिल रही है और इफ यू आर एंजॉयिंग द सेशन, एंजॉय करने का मतलब है, मतलब आपको लगता है दिस सेशन इज यूजफुल फॉर एनी कॉम्पिटिटिव एग्जाम्स, देन सिंपली सब्सक्राइब द चैनल सो दैट यू विल गेट द नोटिफिकेशन अबाउट ऑल कमिंग सेशंस. अब होगा क्विक रिवीजन इन मंथ ऑफ व्हाट? अक्टूबर, नवंबर एंड व्हाट? दिसंबर. एंड इफ यू आर एंजॉयिंग द सेशन, लाइक द सेशन, ताकि आपको लगे कि हाँ भाई ये वापस आपको रिवीजन करना है, फिर से आप देखिए. एंड देन गाइज अब थोड़ा सा आपको फिर कमांड होगी. चलिए एक बार रिवाइज कर लेते हैं क्विक. और पीडीएफ आपको मिल जाएगी ऑन माय ऐप. तो सब एवरीवन प्लीज इंस्टॉल द ऐप. दैट लिंक इज गिवन. ओके, तो दैट इज द क्वेश्चन. तो दिस इज द सॉल्यूशन फॉर दिस वन. This is the C equivalent. Tell me any doubt, then next question. Okay, now next one. Because the capacitor will discharge and the current will flow from V1 to towards what V2. Always current flow from higher potential to what lower potential. Right? Current flow from higher potential to what lower potential. That's why the C1 will discharge and C2 will charge. That is the reason. Is it clear? Next. Next question. Again, it is a very good question on inductor. What is the question here? Now, assuming that I0 is 10 ampere, calculate the IT and IXT in the circuit of figure. I0. Okay. If initial current through the inductor it is given. Initial current through the inductor is given. Calculate the IT and IXT. What is the meaning of the IT? You have to find the I for what? T greater than 0. This is the equation of that I. In the circuit of figure. This is again the question from standard textbook, that is the Sadiku. And how we can solve? Then first of all, remember, if any diagram it is given, then you can use this equation. I final minus I final minus I initial e raised to power minus t by tau. Okay. Now guys, initial current is given 10 ampere. Final current. Remember, this is a resistor, that is a resistor. And what is this? 0.5 Henry and current through the inductor is I, and that current voltage source, this is called current controlled voltage source, depends upon that current. Exactly at t equal to infinite, that current will become 0. So what about this? Also become 0. So inductor will dissipate its energy through what? These resistors. पूरी एनर्जी डिसिपेट हो गई, तो इंडक्टर के क्रॉस करंट कितना है? 0. पूरा का पूरा करंट 0 हो गया. तो एट द लास्ट what is the energy? 0. And that's why the current across the inductor is also 0. Source free है ना, there is no other source, there is no independent active source, there is no independent current source, no independent voltage source, and that's why the what is the final current? 0. Final current is what? 0. Now you have the initial current, you have the final current, then time constant is required. This is an important question on what? Time constant. How we can find the time constant, guys? Okay, then, so is it audible? Okay, then. Now time constant means first of all, watch this. This is the 2 ohm, this is the 4 ohm. Time constant is L by R equivalent, or RTH we can say. So what is the value of L? 0.5 Henry. And you have to find the RTH across what? A and B. Remove the inductor and find the RTH across A and B. But there is a current I, remember. This is a current I, because on this current, this depends upon that current. Now how we can find? First, remove the inductor. And then this is 2, this is 4, this is 3i, This is 4 ohm, 2 ohm, and this is what? 0.5 Henry. To remove it, but remember this is the current I. There is a dependent source. So what is the method here? We are connecting a battery. We are connecting a battery of voltage what? 1 volt. This is the method to find the RTH. And let this current is I. So what is the RTH will become? 1 volt divided by I. And that is the equation. This way find the RTH across A and B. This is the method if there is a dependent sources network. Now, what is the relation between this I and that I? Small I is equal to what? Minus of capital I, or minus of capital I. That's why you can replace it by what? Minus 3I. Minus 3I. Now this is 1 volt, and that's why what is the voltage at this point? 1 volt. That is the reference. Now just to find the 1 by I, what is the incoming current at this branch? I. What are the outgoing current? 1 minus 0 by 2, 1 by 2, plus 1 minus of minus 3I. 1 minus of minus 3I upon 4. You can take 4 as a LCM. 2 plus 1 plus 3I. This will become 4I is equal to 3 plus 3I. What is the I? I will become what? 4I minus 3I is I will become 3. So what is the 1 by I? 1 by 3. So that is the value of what? RTH. That is the value of what? RTH, 1 by 3 ohm. So this is the question on what? Thevenin's resistance actually. This is the question on Thevenin's resistance, guys. It will become I is equal to 3, and therefore 1 by I is equal to 1 by 3 ohm. One by 3 ohm. When I am putting the 1 by 3, it will become 1.5 second is the time constant, guys. 3 by 2. Time constant. The time constant is L by RTH, and now you have the RTH. So it will become 0.5 means 1 by 2 upon 1 by 3, and that is the 3 by 2 seconds. Time constant is 3 by 2 seconds. So calculation is what? First of all, remove the inductor. Put a 1 volt battery here. Remember, but there is a current I in this branch, and because that current depends upon this, you can't make it 0 I. Then what is the relation between capital I and small I? That will become what? Minus I. Okay. Then you can replace it what? By minus 3I. Write down the KVL. What is the incoming KCL? We are writing the KCL at this point. Kirchhoff's current law, nodal equation. 1 by 2 plus 1 minus of minus 3I, which will become plus. This is the 1 minus of minus 3I upon 4. Take the 4 as LCM. This will become 2 plus 1 plus 3I minus minus plus. And then this is the 4I. Yes, calculation is correct, na? Yes. 1 by 3. Yes. I is equal to 3, 1 by 3, and this is a 3 by 2 seconds. Now, you have what is the infinite 0, what is the initial current in the question it is given. So I will become I0 e raised to power minus t by tau. So 10 e raised to power minus t by 3 by 2. So it will become 2 by 3 ampere. And this is the answer. This is the answer for your question, guys. This is the answer for your question. 10 e raised to power minus 2 by 3 t ampere. This is the current through the inductor. Current through the inductor. 10 e raised to power minus 2 by 3 t ampere. And remember, guys, this is the question again from standard textbook Van Valkenburg. तो कैसा हो रहा है दशहरा का यूज? एनी कमेंट्स गाइस? ऑल अदर स्टूडेंट्स, हैप्पी दशहरा। क्या है, दशहरा है, फिर आएगी दीपावली, नंबर ऑफ फेस्टिवल्स. यू हैव टू इफेक्टिवली यूज ऑल दीज हॉलीडेज इफ यू वांट टू क्रैक दिस कॉम्पिटिटिव एग्जाम्स. बहुत ही इफेक्टिवली आपको यूज करना होगा। ओके, देन अब आते हैं, एक और क्वेश्चन पूछा है इसमें, व्हाट इज द वैल्यू ऑफ द आई एक्स टी, व्हाट इज द वैल्यू ऑफ द आई एक्स इक्वेशन। Just if you want to find the Ix, you have to find the voltage across the inductor, because that is the voltage across this. So VL by 2, VL by 2 will become what? Ix. VL by 2, and VL is the voltage across the inductor. And what is the voltage across the inductor? L di by dt. L di by dt. What is the L? 0.5. What is the differentiation of this? It will become 10 minus 2 by 3, 10 into minus 2 by 3 e raised to power minus 2 by 3t. So this is the voltage. Now you can find here this 2, that 2 is cancelled, minus 10 by 3 e raised to power minus 2 by 3t. Now what is the current? VL by 2 divided by 2, so you will get the minus 5 by 3 e raised to power minus 2 by 3t, right? That is the answer. That is the answer. And now watch it carefully. What is the voltage across the inductor? Negative. Voltage across the inductor is what? Negative, right? Negative means you have to change the polarity. Here it is a minus, here it is a plus. Means, what is the meaning of that? This inductor will deliver the energy, because when I am changing the polarity, this will become minus, this will become plus. Current enter through the minus, leaving the plus. Means, what about this inductor? This inductor will deliver the energy, not absorbing. It will deliver the energy to the system, and that's why we are getting the negative voltage. Inductor is discharging actually, and that's why it is an exponentially decreasing function. And when we are differentiating, this is the voltage, and when it is divided by 2, you will get the Ix. That's why Ix is equal to 5 by 3 e raised to power minus 2 by 3t ampere. What is the I? I is nothing but inductor current. Right, this is the 10. And what is the voltage across the inductor? L di by dt, and that is negative. Easy. This is the question on what? Time constant. How to find the time constant. Try to solve this type of questions. I will solve more and more question. जैसे जैसे एग्जाम पास आएगा और ज़्यादा हम लोग क्वेश्चन अच्छे से सॉल्व करेंगे. Now, वन मिनट, अभी मैंने आपको एक क्वेश्चन दिया था. Yes, watch this question. This is the question from what ISRO exam, and that is a second order circuit, guys. No doubt, I have given number of questions. We will solve again. I am going to take one session on that. Again, we will solve what number of questions on transient. But first of all, this question: a steady state is raised in following network at t equal to 0. Find the time when VCT will be maximum. We have to find the VCT. What is the time at which you are going to get the VCT maximum? If you want to find the VCT maximum, so what is the concept here? from mathematics. If you want the time at which VCT maximum, then first of all get the equation of VCT, then differentiate it and equate it to what? 0. You will get the time at which it will become maximum. That is the method. Differentiate it and equate it to what? 0. Because at maximum point the slope will be 0. Now if you want to find the equation across this capacitor, remember here it is an inductor, here it is a capacitor, it is a second order circuit. You will get the second order circuit, right? So I will give you a very simple shortcut to how we are going to get the equation, and then finally time. थोड़ा इसरो का क्वेश्चन है तो याद रखिएगा, थोड़ा सा होता है, आ सकता है गेट में भी. Now which answer is correct, that is the question. Now guys, first of all, this is the 4 UT and that is the 5 ampere. Then how we are going to find the equation? It is a second order. Then first we have to find what is the initial voltage across the capacitor. So for t less than 0, t exactly at 0 negative, circuit is in steady state. This is the DC source. So inductor acts as what? Short circuit. Capacitor acts as what? Open circuit. And remember this 4 UT. What is the meaning of the 4 UT? This is the current source. It is 0 for t less than 0. It is 4 for t greater than 0. And that's why for t less than 0, this will act as what? Open circuit. So you can remove it. This will act as open circuit. Then you can remove it. Let's just remove it. When just we are removing, an inductor acts as what? Short circuit. Make the inductor short circuit. Capacitor acts as open circuit. Open circuit means there is no current through the capacitor. So what about the 5 ampere current? 5 ampere current will flow through the inductor. So if this is the question for this particular diagram, what is the voltage across the capacitor? What is the current through the inductor? Remember, inductor does not allow sudden change of current, 5 ampere. And what is the voltage across the capacitor? This is the voltage across the capacitor. 5 ampere will flow. So what is the voltage? 5 into 3. Because what is the voltage across the inductor? 0. 5 into 30. 150 volt. 5 into 30, that is 150 volt is the voltage across the capacitor. Capacitor does not allow sudden change of voltage. And that is the initial voltage across the capacitor and initial current through the inductor. Now, as you know, under steady state, exactly at t equal to infinity, what will be the voltage? Because there is a source here, 5 ampere and so on. So now what is the diagram at t equal to t greater than or equal to 0? You will get this type of diagram. Now for t greater than 0, this is also available because it is ut. So 4 is also available. This VCT is also available. And then guys, there is a source of 5 ampere and 4 ampere, and that's why if you want to write the VCT, it has two solutions. One is called steady state solution and one is called transient solution. In my class, in my theory class, already I have given in second order circuit, if there is a active independent sources, then we have the two solution, steady state solution plus transient. Then I am going to give you the idea how to find the steady state solution and transient. Here the voltage has the two solution as well as the current through the inductor has the two solution. Steady state plus what? Transient. So steady state solution, it is very easy to solve. Steady state means exactly at t equal to infinite, this inductor will act as short circuit, capacitor will act as open circuit. Again, inductor will act as short circuit, capacitor will act as open circuit. Can you find What is the current here? Now, this is the 4 ampere current. Inductor acts as short circuit. This is the resistor. Capacitor acts as open circuit. This is the 5 ampere. This is the 4, this is the 5. What is the current here? 5. Why? Because the current through the capacitor is 0. So what is the current through the inductor? 9. And that is called steady state value, guys. If it is asked what is the steady state value across the inductor, then this is the current, infinite, 9 ampere. 4 plus 5, 9. And now, what is the voltage across the capacitor? Again, 5 into 30. Because there is no resistor, you can write a KVL in this loop. 150 volt. So, under steady state, voltage across the capacitor is 150. Initial condition voltage is what? 150. So, you can get this value 150. Okay, 150. Steady state value, steady state value. Then, how to find the transient part, guys? How to find the transient part? Just if you want to find the transient part, then first of all, I am giving you just easy method. Just remove this, because it is a natural response of the circuit. Let there is no forcing function. Let there is no forcing function, right? If there is no forcing function, then you can remove this and that. Then, guys, first of all, just to find the transient part, natural response, remove this. Current source acts as open circuit. If it is a voltage source, then it will act as short circuit. Remove this. Suppose I am going to remove this. It is a series RLC circuit. In series RLC circuit, what is the value of the alpha? What is the value of the alpha? R by 2L. This will become 30 divided by 3 into 2, 6, and that is the 5. Alpha is 5. What is the omega naught? 1 by root over LC. 3 into 1 by 27. This is the 1 by 27. This will become root of 1 by 9, and that is the 3. So this is the, we have the idea that for second order circuit, if you have the series RLC circuit, so what are the roots? Minus alpha plus minus root over alpha square pi minus omega naught square. And here the alpha is greater than what? Omega naught. Alpha is greater than omega naught. And what is the value of alpha? 5 plus minus 5 square minus 3 square. So it will become 15 minus 3, 16. And what is the root of 16? Plus minus 4. So what are the roots, guys? Minus 9 and minus 1. Minus 9 and minus 1. Or in a theory class already I have given, if both the roots are real and repeated, these are real and repeated, real and distinct. If the roots are real and distinct, response is what? Overdamped. Response is overdamped. Now, if the response is overdamped, then general formula for the transient part will become K1 e raised to power first root plus K2 e raised to power second root. K1 e raised to power first root and K2 e raised to power minus second root. Then what is the general, what is the complete solution? We have the transient part. What is the transient part? 150. What is the, what is the steady state part? 150. What is the transient part? This one. But we have no idea about the K1 and K2. We can find. So what is the complete solution here? The complete solution will become transient plus steady state. What is the transient steady state part? 150. What is the transient part? This one. And this is called complete solution. But before differentiation, you have to find the value of what? K1 and K2. So how we can find the K1 and K2? Now watch this. Just to find the K1 and K2, we need two things. One, VC0 negative, VC0 positive, and VC0 positive is on 150, we have idea. Second, we need what? dVc by dt. I'm not using the Laplace, guys. You can use the Laplace, but I'm not using the Laplace. I'm just giving you the second method. How we can find the dV by dt? How we can find the dV by dt? Initially, watch this. What is the initial voltage across the capacitor? 150 volt. Now tell me, exactly at t equal to 0 plus, exactly at t equal to 0 plus, let this is the diagram at t equal to 0 plus, what will be the current through the capacitor? What will be the current through the capacitor exactly at t equal to 0 plus? So exactly at t equal to 0 plus, if you want to find the current, inductor does not allow sudden change of current. What was the current through the inductor? 5 ampere. Capacitor does not allow sudden change of voltage. So exactly at t equal to 0, what is the voltage across the capacitor? 150 volt, and this is the 5 ampere. Now watch this. If this is the 5, it is the 4. So what is the current from this? 1, it is 4. 4 plus 1, 5. Inductor does not allow sudden change of current. So yes, 5 ampere. The initial current was 5 ampere. This is satisfied. Now what is the initial current through the capacitor? For example, this is the 5. Out of 5, here it is a 1. What is the current through the capacitor? 4. You can say IC0 negative, IC0 positive is what? 4. And what is the current through the capacitor? C dVc by dt. IC0, that is equal to 4. So what is the dVc by dt? 0 plus. Initial condition. That will be the objective question, guys. Remember, IC0 upon 4. IC0 upon C. So this is 4 upon 1 by 27, and it will become 108 volt per second. So dVc by dt is the 104, that is the 108 volt per second. If it is asked question, what is the rate of change of voltage exactly at t equal to 0, you can find. So first of all, exactly at t equal to 0 plus, current through the inductor, voltage across the capacitor, put the value, fixed value 150, fixed value 5 ampere, then you can find the voltage at this point. Now voltage and then current. What is the current? 5 minus 1, that is the 4. Then equate it, 108 volt per second. Now what is the use of this? If you have both the value, you can find the K1 and K2, guys. For example, exactly what is the differentiation of this? Differentiation of this will become, this is the general formula, it will become minus 9 times of K1 e raised to power 9t plus minus differentiation of that K2 e raised to power minus tt. Okay. Exactly at t equal to 0, put the value 0. What is the value of the Vt? 150 is equal to 150 plus K1 plus K2. 150, 150 cancel out, and that is K1 plus K2 is equal to 0, and what is the K2 is equal to minus K1. So from one initial condition, that is the K1, and what the relation between K1 and K2. What is the second initial condition? dV by dt. What was the dV by dt? Already we have calculated. Initially the dV by dt was, what was the value? 1 minute, I have calculated now. Yes, 108 volt per second. So you can put here exactly at t equal to 0, 108, this will become minus 9k1 minus k2. This is t e raised to power 0 is 1, e raised to power 0 is 1. What is the k2? Minus k1 minus minus, it will become plus. Minus 8k1. So what is the value of the k1? 108 by 8. Guys, this is nothing but 27 by 2. Minus. If it is minus, then what is the k2? K2 will become plus 27 by 2. So you can get the complete equation. If this is the question in GATE exam, so what is the response? What is the complete solution for that? Now you have both the formula, then complete solution for this is, for this particular circuit is lengthy question, no doubt, but if you are going to solve it, it is a very, very conceptual question. 150 minus 27 by 2 e raised to power 90. This is the value of k1. 108 by 8, that is the 27 by 2. Divided by 4, you will get. Then everything is fine, no? Yes. Okay. Then plus 27 by 2 e raised to power minus t. This is called complete solution. This is called what? Complete solution for VCT. But what is asked in the question? This is the ISRO. Sometimes in ISRO, they are just giving the question to just for your what? To disturb your time management. The number of students are trying to solve in competitive exams. If you have the trick how to solve it, then quickly they can solve. Otherwise, it will waste your time. बहुत ज़्यादा ना टाइम मैनेजमेंट आपका डिस्टर्ब हो जाता है कि यार कैसे सॉल्व करना है, क्या करना है और कैसे बनाएंगे. तो इसको थोड़ा सा ध्यान रखो आप लोग. ऐसे क्वेश्चंस एग्जाम में अगर आपको क्लिक कर रहा है तो बनाइए, नहीं तो देखो ये तो मैं मेथड बता रहा हूँ कि इनिशियल कंडीशंस कैसे निकालते हैं एंड सो ऑन. अब आ गया दिस वन फाइनली. तो डिफरेंशिएट इट. व्हाट इज द डिफरेंशिएशन ऑफ दैट एंड इक्वेट इट टू 0. दिस इज 0. दिस विल बिकम माइनस माइनस प्लस 27 by 2 into 9 e raised to power minus 90 minus 27 by 2 e raised to power minus t. Equate it to 0. 0 means 27 by 2, 27 by 2 becomes 0. 9 e raised to power 90 minus e raised to power minus t is equal to 0. And now it will become, this is cancel out, it will become 8t is equal to 1. Then it is e raised to power 8t is equal to 9. Put the log here, log of 9. Then what is the time at which you are going to get the maximum value? It will become 1 by 8 log of 9. That is written as log of 9 raised to power 1 by 8. What is the 1 by 8? 0.125. 0.125 log of 9 raised to power 0.125. No need, calculator not required here. And that's why the answer for this question is this one, log of this. And that is the question from ISRO exam. Okay. तो ये देखिए. So what we have done, just we have to find the complete solution or complete voltage across the capacitor, then differentiate it and equate it to 0. What is the procedure here? First we will have to find the initial voltage across the initial voltage across the capacitor, current through the inductor. So exactly at t equal to 0 negative, make it what? Open circuit, make it short circuit. Ut will act as 0, current source act as open circuit. Find the current through the inductor. Find the voltage across the capacitor. Inductor does not allow sudden change of voltage. Capacitor does not allow, inductor does not allow sudden change of current. Capacitor does not allow sudden change of voltage. Now then guys, for t greater than 0, this is the diagram. Because it is a RLC circuit, it has the two solution. One is called, because it has the independent sources also 5 and 4, two solution. One is called steady state solution and one is called what? Transient solution. Then this is the steady state exactly at t equal to infinite. The steady state solution means exactly at t equal to infinite. Inductor act as short circuit, capacitor act as open circuit. So what is the steady state solution for current through the inductor? 9. And what is the steady state voltage across the capacitor? Again 150. Initial voltage is 150, right, and final voltage is 150. Then how to find the equation? It has, suppose you want that what for transient part, what you can do, just for transient part remove the independent sources, both the current source, make it 0. You will get the series RLC circuit R, L and C. Then you can find the alpha, that is the basic rule, R by 2L and omega naught is 1 by root over LC, and that is the alpha. And these are called the roots. If the roots are real and distinct, then the response is overdamped. This is the overdamped response, k1 e raised to power minus 90 plus k2 e raised to power minus t. This is the transient part. Before finding the k1 and k2, always write a complete equation, steady state plus steady state part plus transient part. When we are having the steady state plus transient, this is the complete solution. In complete solution, we have the two unknowns, k1 and k2. Just to find the two unknowns, we need what? Vc0 as well as dVc by dt 0. Because we have to find the two equations. So Vc0, what is the Vc0? 150. So you can put here 150 and that is the equation. From this, you will find one relation between k1 and k2. Just to find the second relation, you have to find the dVc by dt 0. So you just to find the dVc by dt 0, draw the diagram at 0 plus. Proper KCL, this is the 4. Inductor does not allow sudden change of current, it will remain 5. This is what? This is 1 ampere, 1 plus 4, it is 5. This is 5. 1 is going this side, so what is the current here? 4. The initial current through the capacitor is 4. What is the initial current? C dVc by dt. In this way you can find the what is the dVc by dt. dVc by dt, that is the 108 volt per second. That is the question. What is the dVc? This will be the question. This is the 108 volt per second. Now, finally, you can put all these values. You can get the first complete solution, 108 exactly at t equal to 0, minus 9 k1 and k2, and you will get the active values of what? K1 and k2 to minus 27 by 2 plus 27 by 2. Put this value, you will get the complete solution, 150 minus 27 by 2 e raised to power minus 90 plus 27 by 2. This is again a question, what is the complete solution? Now, after that, time is required, at which time voltage across the capacitor is maximum. You have to differentiate it. When we are differentiating and equating it 0, put the proper log and you will get final answer. This is the final answer. सोचिए एक क्वेश्चन में कितने क्वेश्चन है भाई, एक क्वेश्चन में कितने सारे क्वेश्चंस हैं. ओके, क्या लैपलास का यूज करके बना सकते हैं? यस और नो? Can we use the Laplace transform to just to find the equation? At the last you have to differentiate it to find the maximum. But आप इसको क्या किसका यूज करके भी बना सकते हो? Laplace transform का भी यूज करके बना सकते हो, right? Laplace transform का भी यूज करके बना सकते हो. But remember, if you have the initial voltage across the capacitor, if you have the initial current through the inductor, then you have to replace the inductor and capacitor from time domain to what? Frequency domain. So already in my class I have given. Any other students, if you want, then please write me comments. तभी इसको हम लोग सॉल्व करेंगे by using the Laplace. अदरवाइज मैं सॉल्व कर रहा हूँ, आप नोट कर रहे हैं या नहीं कर रहे हैं, नो आइडिया. Anyone, if you want the PDF, that PDF will be available on my app, Prep Funda. Already it is given in description, everyone. You can download now. Just after the class, I will upload the PDF. Go through it. Now, if you want to solve this question by Laplace, then find the initial voltage through the inductor across the voltage already we have, that is the value 150. And what is the initial current through the inductor? 5 ampere. Voltage across the capacitor, and this is the current through the inductor. Now, this current is a 4, and let this is the current through the inductor I. So, what is the current here? It will become 4 minus I. 4 minus I, right? This is the 4. What is the current through the inductor? Let it is I, that it will become 4 minus I. What is the current here? Let it is 5. So it will become 5 plus 4, 9 minus I. 9 minus I, right? Just I am giving you how to write the differential equation. Then guys, you can write a KVL in this loop. Just I have applied the KCL, that this current is I. This will become 4 minus I. Then this is the 5 and so on. This is the 5 plus 4, 9 minus I. And now write down the KVL. So how you can find the differential equation? This will become 30 times of 4 minus I plus VC. Just I am writing the voltage across the VC. I am not writing the current, just VC, because I want VC. Then this is plus, this is minus. It will become minus L di by dt. Minus L di by dt. Why minus? Because the current, we are moving in this direction. So minus di by dt, right, is equal to what? 0. So this is the equation in terms of what? I. How we can find the relation between I? So always remember, this is the current through the capacitor, IC. What is the current through the capacitor? 9 minus I. And the current through the capacitor is given by C dVc by dt. And C is 1 by 27. So what is the I here? I will become 9 minus C dVc by dt. You have to replace the 9 by I by what? 9 minus C. So you will get the differential equation. This will become 120 minus 30I plus VC minus 3 di by dt. This is equal to, this is easy guys, don't worry about that. You will get the equation. तो देखो अभी आ गया 9 minus C dVc by dt, put here. This will become 120 minus 30, 9 minus C dVc by dt plus Vc minus 3 d by dt of 9 minus C dVc by dt. Okay, then 120 minus 30, 270 minus plus 30C right plus Vc. Now what is the differentiation of 9? Common, constant 0. And what is this? Minus plus d square Vc by dt square is equal to 0. Now this is a second order differential equation guys. This is the second order differential equation. 270 minus 120, it will become what? 150. And you will get 3C d square Vc by dt square plus 30C dVc by dt plus Vc is equal to 150. It is a homogeneous or non-homogeneous? Non-homogeneous differential equation, guys. So non-homogeneous differential equation, now what you can do, you can differentiate it, or you can put the Laplace here. You can put the Laplace here and try to solve it. This is the method. Or directly you can replace the capacitor by what, 1 by SC, and inductor by what, SL, and you can put the initial value of the current and voltage across that, and again you can apply the KCL and KVL. There are number of ways. Just I have given the hint. Find the proper differential equation. Just at the end I am giving you the proper differential equation and try to solve it. This equation is divided by 3C. So you will get a proper differential equation here. Watch this. 3C plus 30C plus VC is equal to 150. If you are going to divide it by the 3C, it will become plus 10 plus VC by 3C, 150 by 3C. Now remember, what is the C? 1 by 27. So 1 by 27, guys, if suppose I am going to put the 1 by 27, it will become 9. Therefore, plus, and then 1 by 27, 1 by 9, 150 into 9. 150 into 9, 1350. Okay. This is the equation, differential equation. अब भाई देखो इतना लंबा आ गया डिफरेंशियल इक्वेशन. Okay, 1 minute. There is one problem. If it is divided, yes, everything is fine, na? Now, what is this? Homogeneous or non-homogeneous? Non-homogeneous differential equation. If you are going to find the roots, again you will get the same roots. -1 and -9. So, why you are so much calculation? Already I have given you the shortcut, how to find the roots, how to write the general equation, and then how to find the values from the initial conditions. Last point, but not the least, if you want to solve by the Laplace, then so you can solve this differential equation. Already I have given you the answer right now. If you want to solve it by the Laplace, you can take the Laplace of this differential equation. What is the Laplace of that? S square something and so on, right? You can find the Laplace, or just it is lengthy. Then Laplace, 1 minute. You can replace the inductor if you have the initial current, then you can replace by this. This is the 3 Henry mean, this is the SL, and this is the initial current. Now resistor, and this is the capacitor. Capacitor is replaced by 1 by SC, and there is the voltage source. This is given by initial voltage upon S, and this is the 5 ampere current source. This is replaced by 5 by S, and that current source is replaced by the 4 by S. Inductor, it is replaced by there are two methods to replace the inductor. One, and in parallel there is a current force that is given by I naught, initial current through the inductor upon S, and what is this? SL. Right, that is the diagram. अब यहाँ से Laplace निकालो, then या पूरा convert करो. Now you have the initial current through the inductor, that is replaced by 5 by S. Initial voltage across the capacitor 150 by S. and R is what? R will remain R30, and this is 1 by CS. 1 by CS. Inductor capacitor is replaced by 1 by CS, and then you can write what? KVL और KCL, and you can find the equation and then you can solve it. अब बताइए कौन सा मेथड? टाइम डोमेन में देखो मैंने आपको विद इन सेकेंड्स विद इन मिनट्स आपको सॉल्व करके दिया, तो आपको जो भी मेथड लगता है इस एक पर्टिकुलर क्वेश्चन के लिए यू कैन यूज. ऑलरेडी आई हैव गिवन यू द हिंट. अगेन इफ यू वांट द सॉल्यूशन इन टर्म्स ऑफ व्हाट? लैप्लास, इन टर्म्स ऑफ डिफरेंशियल इक्वेशन, राइट कमेंट्स में लिखो कि सर हाँ इसको सॉल्व करते हैं, चलिए, तो देन आई विल सॉल्व. ओके, अलग अलग मेथड है क्वेश्चन को सॉल्व करने के. तो होप अप टू दिस पॉइंट यू हैव एंजॉय द सेशन गाइज. एक और सेशन लेंगे जिसमें और भी क्वेश्चन सॉल्व करेंगे. अभी ट्रांजिएंट बहुत लंबा पार्ट है, तो सेकंड पार्ट वी विल सॉल्व द मोर क्वेश्चंस ऑन दैट. एवरीवन like the session, share the link of this session and subscribe my channel, and remember, go through the UPSC website, that is upsc.gov.in. जब भी आपका विंडो ओपन हो तो आप अगर एलिजिबल हैं फॉर इंजीनियरिंग सर्विसेज एग्जामिनेशन तो अपना फॉर्म भर दीजिए. दैट इज गोल्डन अपॉर्चुनिटी फॉर यू, एंड स्टार्ट योर प्रिपरेशन नाउ. आप अगर अपनी प्रिपरेशन स्टार्ट करेंगे, डजेंट मैटर आपका सेमेस्टर कैसा हुआ था या आप उस समय पढ़ाई में कैसे थे, अगर आप यूपीएससी देना चाहते तो याद रखिए बीटेक होना चाहिए. पीएसयूज में कंडीशन है 60% से ऊपर, 65, 75, बट यहां पर ओनली डिग्री चाहिए. अगर आप थर्ड डिवीजन भी पास हैं तो भी आप इंजीनियरिंग सर्विसेज एग्जाम दे सकते हैं, क्योंकि यूपीएससी आपको भरोसा करता है कि सुबह का भूला अगर शाम को घर आ जाए तो उसे भूला नहीं कहते. मतलब आपको सुधरने का, आपको संभलने का एक और मौका देता है यूपीएससी. इसीलिए आपको बीटेक का रिजल्ट अगर बेकार भी है तब भी आप एफर्ट लगाते हैं. वहां पर कोई क्राइटेरिया नहीं है कि आप इंजीनियरिंग सर्विसेज एग्जाम नहीं दे सकते अगर आप थर्ड डिवीजन से पास आउट है, लेकिन पास आउट होना जरूरी है. ओके, ओके देन, थैंक यू, हैव अ नाइस डे एंड हैप्पी दशहरा.